Alright, what's up guys? In this video we're going to pick up some more calculus here. It's going to be another integration practice video. This is going to be example number 43 of our integration practice series. Okay, so we got a definite integral here from 1/2 to the square root of 3 all over 2. We got x squared divided by 1 minus x squared dx. So what we can do here is just use a trig substitution. And if you're still kind of struggling with that concept, the trig substitution, like I did plenty of videos on that. So in this case, if you notice, we have a squared minus x squared is what we have. So remember, when we have that, that means that x is equal to basically a sine theta. That's if the a squared minus x squared is what we got. The secant one is when the x squared is first and not the a squared. If the a squared is first, it's sine. If the x squared is first, then it's the secant substitution. And so that's what the trig substitution is. So that means that x here is going to be sine theta. So we need dx, which is cosine theta d theta. That's just derivative of that. And so now we just go to the integral, and all we have to do is plug stuff in, and we'll clean it up. Now the limits here from 1 to 2, and then from the square root of 3 all over 2, we're gonna have to change those, so we'll leave the limits blank. So we'll have sine theta squared all over the square root of 1 minus sine theta squared. And we need to multiply that by, of course, our dx, which was the cosine theta d theta. So that's what we'll need to do. So let's clean up the square root first. So for the square root part, we got 1 minus, well, if we square that, that'd be 1 minus sine squared theta. So we have the square root of 1 minus sine squared theta, which we know can be written as the square root of cosine squared theta, which is just gonna simplify down to cosine theta. So if we go back to the integral and we go ahead and multiply, we'll have sine squared theta when we simplify the top, multiplied by cosine theta, and then down here at the bottom we'll just have the cosine theta and then d theta. The cosines cancel out, so now we're just left with the integral sine squared theta d theta. So we can use a half angle identity for that. So if you recall that sine squared theta, that's just 1/2 multiplied by 1 minus cosine of 2 theta. So I'm going to replace the integrand with that. So, and the 1/2 is a constant, so I'm actually going to bring that out. And we'll change the limits in just a minute. So we'll have 1 minus cosine of 2 theta d theta. Okay, so let's get the limits out of the way. So if we go back, remember x was sine theta. So that means that theta is arc sine, or sine to the negative first. And it's going to be basically 1 over 2. When I stick that in, if I stick in the 1 over 2 here, well, what is arc sine of 1/2? Well, arc sine of 1/2, that's pi over 6. Now I have to do the same thing for the square root of 3 all over 2. So we'll do that next. So again, you know, theta, that's arc sine, or sine to the negative first. And this time I just simply stick in the square root of 3 all over 2. So arc sine of the square root of 3 all over 2, that's pi over 3. Yeah, I'm trying to visualize the unit circle in my head. Yeah, pi should be pi over 3. So what that means is those will be the new limits. So the limits will now be from pi over 6 to pi over 3. Okay. Now, again, 1/2 is just a constant, and now we have the limits that we need for the inside here. So this is really what the integral becomes now. Okay. So let's do those, and we're pretty much almost done. We just got to finish up this last little bit. Okay. So from pi over 6 to pi over 3, we have, we're integrating this constant with respect to theta. Well, that's just theta from pi over 6 to pi over 3. So you'll have that here. So this would be pi over 3 minus pi over 6. Pi over 3 minus pi over 6, that's pi over 6. Now we got to do the integral from pi over 6 to pi over 3. And we got cosine of 2 theta d theta. Hopefully you have that antiderivative memorized. Remember, it's 1/2 sine of 2 theta. And it's going to be from pi over 6 to pi over 3. If you're not sure how I got that, do a u substitution and you should get that. If you do a u substitution and do it by hand, you would change the limits. But since I already knew the antiderivative off the top of my head, I can just keep the same limits. But if you actually wanted to do it by hand and actually do the u substitution by virtue of the substitution method, you would change the limits. So your limits wouldn't be from pi over 6 to pi over 3 if you actually chose to do it that way. So it's best sometimes to just make sure you have some of these basic antiderivatives memorized. That way you can just, you don't even have to go through the whole process of subbing things in. So again, we sticking out pi over 3 here. So we got 1/2. We got sine of 2 times pi over 3. And I think it's going to give me the square root of 3 all over 4, if I remember correctly. I'm pretty sure on that. And then sticking in pi over 6, we'll get 1/2 sine of pi over 6. That's also going to be the square root of 3 all over 4. You can check me on that, but I believe that's correct. So when we subtract those two away, we'll get 0. So really what we're looking at is 1/2 multiplied by pi over 6 plus 0. Not plus 0, it's actually minus 0, excuse me, minus 0. Which is essentially just 1/2 times pi over 6, which is obviously pi over 12, which actually be the answer. So your final answer here would be pi over 12. So that's your answer to this integral. So the integral at the beginning was the integral from 1/2 to the square root of 3 all over 2, and it was x squared over the square root of 1 minus x squared dx. So the answer is pi over 12. That's the solution. All right. So typically the definite integrals for the trig substitutions take less time to complete, whereas with the indefinite integrals, it requires a little bit more work for the indefinite ones than the definite ones. The definite ones tend to be a lot quicker to compute than the Okay, so that is your answer. So let me know if you got any questions, and I will see y'all next time.